get into the big topic of open source, something that we actually say at Red Hat.
This is so awesome.
We are an open culture that believes
It's actually
in
a big piece
what is that process that a developer, or let's say,
as the Kubernetes ecosystem really boomed.
Hello and welcome to this week's Ask an OpenShift Expert Office Hours. I am co-host Andrew Sullivan, joined by my other co-host, Jonny Rickard. How are you, Jonny?
I'm good, man. How are you?
We were busy chatting and lost track of time. And so when I clicked the button to go live and start the video, it's like, oh crap, I forgot to refill my coffee. So I jumped up and ran into the kitchen and filled up my coffee cup real quick. And then I heard Stu's voice and I'm like, oh no, I've only got like 15 seconds left. And so came rushing back in here. So
Time.
it's that's how it's going. That's how it's
Awesome.
going. How you been?
Good, man. Good. Busy. Moving, getting moved in, work, everything.
Yeah, it used to be. I was pontificating about this with a friend of mine recently. It used to be the summer was a little bit slow for us on the tech marketing side because there's not a lot of conferences and events and stuff like that, and that tends to drive a lot of the stuff that we do in tech marketing. In the last couple of years, that hasn't been true. It seems like there's just a constant stuff going on, and for us, the first half of the year is always a crazy sprint. It's a marathon of sprints between Red Hat One and Red Hat Summit and KubeCon and various other things always going on. And then the fall is similar with, again, KubeCon, which is coming up in 2 weeks, I think.
Yep, November.
But also the Summit Connects and just all those other things. So, and winter is holiday season, but also Red Hat One is in January. So anyways, it's just, it's nice to take a breath sometimes. And I miss those days. But anyways, enough of me complaining.
It's a good problem to have. It's a good problem. It's a great problem to have, right? Because if we're twiddling our thumbs, it's probably not going to be good for us in the long run. So,
well, that's the thing, right? Of like, I genuinely love my job because we're always doing highly technical things that are like leading edge, like trying out different things, doing the live stream, right? Getting questions from folks, and like there's always problems to solve, and so it's never a dull moment, which I really, really enjoy.
Yeah.
My wife works in a hospital, and when she works nights, she hates working nights because she's just like, it's boring. Like, unless somebody is like actively trying to, and this sounds really bad and really morbid, but like, unless somebody's like actively trying to die, like it's just boring. And she's like, on the one hand, like it's really nice to be bored because, it means people are healthy. But on the other hand, like it just makes the shifts go by so slow. I'm like, yeah, I get that. Like it's good to have stuff to do.
Yeah.
But anyways, this week, so our topic this week is workload availability. So this is sort of a generic term that we've been using with regard to what is effectively high availability for workloads running inside of OpenShift. And Kubernetes, which of course is the foundation of OpenShift, treats workload availability, high availability, very, very different than something like a VMware or a Red Hat virtualization or even OpenStack for that matter. And so we did an internal presentation a couple of months ago now, on this topic, and kind of walked through how this works with OpenShift, mostly in the context of OpenShift virtualization, because VMs we care about coming back, whereas pods, and containerized applications, we typically expect them to have multiple instances, right? Horizontal scalability, not vertical scalability. So losing a node or three inside of the cluster, or an instance, a pod or two or three, isn't really a big deal. But with VMs, it tends to very much be a big deal. So the goal was to kind of explain it that way. And that was what I wanted to do with this particular topic. So for anybody who watches the feed, on YouTube, right, you've probably seen this topic pop up and down as we've tried to do it multiple times over the last 6 weeks. So we are finally here. We are finally going to do this topic.
We're doing it.
We are, but I'm going to do this one a little bit differently. I personally have not configured some of the components that we're going to be using today, and so I'm going to use Lightspeed. So I really want to, like, I've got a few slides. I want to walk through a few things and explain some concepts and stuff like that. But I've got a cluster, and I want to walk through setting this up. But I'm going to try and do it just by asking Lightspeed and see how it goes. Because we've talked a lot about Lightspeed. We've had the Lightspeed folks on a couple of times. Lightspeed continues to improve. There's the engine behind it, for anybody who's curious. It basically uses a lot of RAG in order to augment the LLM that is configured, because you can bring your own LLM. Augment the LLM with all of the OpenShift documentation and various other assets and stuff like that inside of there. Tangential to that, I'm curious to see if anybody watched the What's New session yesterday. We started to talk about MCP servers, Model Context Protocol, and the OpenShift MCP server, which is the Kubernetes MCP server, is in dev preview, I believe. So having that available, being able to interact with it, I think there's going to be some really cool things that are coming up in that area. Let's see. We have some type of workload in VMware in OpenShift without missing anything from VMware legacy applications. Yes, so that is the goal of today's topic, is to talk about for OpenShift workloads broadly, but really from my perspective, because I spend a lot of time on OpenShift virtualization these days, focusing on how we provide high availability or the ability to restart workloads inside of OpenShift in the event of a node failure. So that's what I'm really talking about. Jonny, I know we spent the 15 minutes in the quote unquote green room beforehand, chit-chatting and catching up on life. Do we have any top of mind topics?
I did share the link to the MCP, the OpenShift MCP server, because it did go out during the What's New yesterday.
Yep.
I was trying to think if there was anything else. I mean, there's a bunch of things going on, but I definitely did not prepare. I think it was more. It's more for what we're gonna do next week. Just we're gonna do a What's New in 420 for admins and recap kind of like what the live stream covered yesterday, but like more specifically for cluster admins. And then coming up in November, we're gonna have the user experience team come back on, and we're also going to have Portworx, right?
Yep.
Portworx, yeah. They're going to come in. I think it was like November 19th, that week right before Thanksgiving.
Yep.
So we did a little pre-brief with them last week. It looks like that's going to be a pretty interesting topic. And then I'm going to really work to try and get more PMs, TMs, engineers on the stream next year, or closing out the year into next year, so that way we have more cool stuff to talk about and learn about.
Yeah. I've had a couple of meetings, basically joining team meetings for product management folks and stuff like that. And there's a lot of folks who want to come on and talk about all the cool stuff that's going on. I will say, and I'll say this quietly so that corporate marketing or product marketing doesn't hear me say this. So yesterday, literally as we were streaming the What's New with 420, the bits for 420 shipped. So 420 is generally available right now if you want to go and pull it down and give it a try. So why did I say that? I'm going to say that quietly so that marketing doesn't hear me, because they're not doing the announcement of 420 until KubeCon. So it is available now, but the release and the launch are decoupled, is the way that the marketing folks do it. So come November timeframe, you'll see a whole bunch of things go out talking about OpenShift 420, all of the new features, capabilities. You'll see lots of demos and all those types of things. But in the meantime, marketing-wise, like lots of publications-wise, you'll see us being a little bit quiet about it. That being said, as always, when we do a new release, new clusters, you can absolutely go in, you can deploy OpenShift 420 today. It is fully supported, all that other stuff. Existing clusters, if you are running 419, you need to use the fast channel to update today. Keep in mind that fast channel is fully supported, so you can do that. But some folks don't feel comfortable using fast channel. Updates in the stable channel take somewhere between 45 and 90 days for them to be basically put into the stable channel. So just keep in mind that that can take some time, but keep an eye out on your update channels whenever you're ready to start doing that with your production clusters. But absolutely, I would highly encourage anyone and everyone to go and start testing 4.20 in non-production immediately.
Yeah, that's awesome.
Catching up on chat here. Dance of different traditionals. So migrating VM from one node to another in VMware is smooth and user-friendly. Can we also have an option in OpenShift where I can select the nodes where to migrate the virtual machine? Yes, that is on the roadmap. In fact, it may even be in 4.20. I don't know. Do I have a 4.20 cluster available that I can check that out on?
I definitely do not, but
let's see. Sorry, I'm looking to see. I know we have it in there is a feature request for that somewhere. So I thought that it was already on there. Let's see. Nope, it's not going to do it for this one. So anyways, there is an RFE for that. I will check with product management to see if we can get some information about when and where that's going to land at. You can sort of do it today already by setting a node selector on the VM and then triggering the live migration. That will force it to land on whatever node you specify it. But very much to your point of like, hey, it'd be great if I could, VMware, you drag and drop it to the host that you want it to go to. Like, it'd be great to have a similar, ability. Tom, we have 2 OpenShift clusters and are using ODF external. Okay, so we are also using ACM to do DR policies for workloads between those clusters. We want to do the same for our OpenShift VMs. Multi-disk VMs are not supported, clone disks are not supported. I know that that's true, but I don't know enough about ODF rather to know why that's not true, or why that's not supported. I do know who we can reach out to. So, Jonny, let's take a note on that one, and we can reach out to the ODF product management as well as ACM product management if they aren't already listening, and we can see if we can get a good answer for that for you, Tom.
Yep, I'm on it.
Yeah, so the only top of mind thing I had was just that 4.20 is quietly available now if you go in and you look on the download pages, but expect just a lot more marketing fanfare, public fanfare. Again, we've got, I think there's like a dozen or more different blog posts that are going to be going out in the early part of November to talk about all the different capabilities. Including, I know, a whole bunch of demos. We've been working really hard to get demos and showcasing how stuff works and all that other stuff. So, all right, let's grab this tab and rearrange.
And not that I didn't believe you, but I just verified in my 419 cluster that the fast channel is there. So I'll update my cluster and start playing around with that because got to know.
Yeah. Let's see. Why is it that I always get spam phone calls right in the middle of these things?
That's how it goes. It's because they know.
All right, I am going to share. I have slides. I'm just going to run through them. Not all of them. I only want to show a couple of things just to highlight some topics and some information. So I don't want to slide us to death here. Instead, I want to show a cluster and show what's going on and like actually get into the meat and potatoes of configuring things. So, how to start with this? So OpenShift and Kubernetes at a whole operate off of the principle of failure is okay, right? Because it's Kubernetes, it's cloud native applications that are deployed as pods. And I use something like a daemon set or a deployment or something like that that keeps a minimum number of those available. And then I use things like pod disruption budgets to keep other sort of cluster maintenance and administrator activities from bringing it below that number. So if I lose a node, it's really not a big deal, right? I probably have 2 or 5 or 20 different replicas of that particular pod already running. The cluster, right, ingress and everything else just automatically takes action and stops directing traffic over to whatever pods were on the failed node. VMs, however, are different because a lot of times that application, there's only one instance of it and it's running on that one virtual machine. So we want to be able to recover those, but we have some challenges. And in particular, with PVCs and virtual machines, we want to have only one of those running at a time. Right? With OpenShift Virtualization, each one of my VM disks is stored in a PVC, and it's an ArcWX PVC, so that way I can mount it on both the source and destination hosts when, for example, doing live migration. But if I act too early, if I don't take some safeguard measures and I accidentally start that VM twice, I'm going to corrupt that underlying disk. So we always want to make sure that we have only one instance, and at most one instance of that virtual machine running at any point in time in order to avoid data corruption. So that's why we have this at most one semantics. And this principle exists kind of in all virtualization solutions, right? With Red Hat Virtualization, Rev, we did that in the same way. We would use the, SPM, the storage controller manager to do it. VMware does the same thing with data store heartbeating and various other mechanisms inside of there. OpenStack does the same thing, right? We all have this thing in the Linux world, we call it fencing, to ensure that only one instance of that VM is running. So in OpenShift, when a node goes into an unknown status, we default to being very careful with the workload that's running on there when we care about recovering it quickly. So what happens, and what you're looking at here on this particular slide, is a node goes down, right, or stops responding for some reason. And the control plane doesn't change the status of that until we have 4+1 heartbeats or check-ins from the kubelet on that node fail. So effectively, OpenShift doesn't even really care that something has happened to the node until 50 seconds have transpired. And at that point, we begin the process of figuring out how to recover the workload inside of there. So the floor, the bare minimum floor that we have for any workload recovery, whether it's a virtual machine or whether it's a pod running inside of OpenShift, is going to be that 50-second marker. Is it technically possible to change that heartbeat timeout? Yes, however, it is not supported because it has a lot of ramifications across other things in the cluster. So I've talked with engineering, I've talked with support, and we don't support changing that number. So once we hit that 50-second threshold, things like node health check with whatever the remediation strategy we have kicks in, and then at that point we can recover that workload, that virtual machine, to one of the surviving nodes inside of the cluster. How long that takes depends on a surprisingly large number of things. So if we look here on the far left-hand side in this blue section, that's that mandatory 50 seconds that we wait for the control plane to declare the node as unknown, right? Something has happened to it. Within OpenShift, we then rely on a feature called the node health check to then do some additional verification or waiting in order to see if our node is going to come back. So node health check by default has a 300-second timeout, 5 minutes, for it to kind of wait for something to happen. Maybe our node simply rebooted and we forgot to tell the rest of the cluster, right? And so within that 350-second, right, 50 seconds for the first one, an additional 300 seconds, maybe the node pops back in and then it registers like, oh, no, all of my workload is gone, and the control plane immediately reschedules it. Or maybe it doesn't. And at that 300-second timeout is when we begin to take remediation action. So remediation is what we use to actually fence that node. So, and I'll talk more about this in a little bit, but there's a couple of different remediation options available, or fencing options available. They can take varying amounts of time as well. So SNR stands for self-node remediation. This is an agent that runs on the node as well as on the control plane, and it relies on the node to take some sort of action to remediate itself. There's also fence agents remediation, which uses basically it uses the BMC on the node, the physical node, and physically reboots that node using the BMC hardware. And then alternatively, there is machine deletion remediation, which we see with things like, if I'm using AWS bare metal, machine deletion remediation basically says, oh, the node is no longer responding. I'm going to literally delete the node from the cluster because it was provisioned by a machine set. So I'm going to delete the node from a cluster, and I'm just going to request the cloud provider give me a whole nother node to replace it. So those are the three primary, or really the three remediation options we have. Once fencing is successful, we go through and we restart the workload. Right? But getting there can take, as you can see on this timeline, by default, a very long time. However, we can tune these things down, and I'll talk more about that at the very end of this. For example, that node health check, that big red block, you can turn that all the way down to 1 second if you choose. Just be aware that it's one of those situations where, and the reason why Red Hat chooses to set very conservative defaults is maybe this is something that doesn't need to have, maybe it's a transient network failure. Maybe it is just a node rebooting and we don't want to have this multi-step thing that can affect it happening, right? All this other stuff. So you, the administrator, the person who is responsible for it, you can make those decisions and you can bring this way, way down. And actually, I'm going to, here, I will skip all the way to the end and show you what those minimum thresholds are. So if we look here, you can see you can tune this all the way down. So take down that node health check weight. So the upstream for node health check is medicates. Take that all the way down to 1 second, right? The host remediation can be as low as 15 to 16 seconds, depending on the type of remediation that you're using. So you can see that this is based off of fence agents remediation. So long as we get that, like the 1 second has expired here, we reach out and say, reboot this node. So long as it comes back and it says the node is rebooted quickly, then we can immediately move on to the next step, which is restarting workload. One of the things that can cause issues here is, for example, when this step, it takes more time than expected. For example, let's say that the node that failed is the node that has the pods or pods responsible for triggering that BMC reset action. Well, now we have to wait for those pods to restart somewhere before it can go and trigger the node reboot. What happens if the node literally fell through the floor, right? There's now a gaping hole in the data center that used to be the rack that held those servers, and everything is unresponsive. Well, that if the agent that's triggering the BMC reboot, if the BMC doesn't respond, we have to wait for it to time out, and that can extend that out as well. So there's a couple of different things that can contribute to making this longer than expected in those regards. All right, so let's talk about, and I'm going to come back up here. Jonny, I'm not keeping a close eye on chat, so please let me know if there's something I should be talking
Yeah,
about.
we got one from the Dance of Different Traditionals. In case of node failure, will the VM automatically move over to another node by default, or is there a specific configuration that needs to be set?
So yes and yes. So if you have configured remediation, so what I'm getting ready to show you is node health check, and then we'll talk about the remediation agents. So long as that is configured, then yes, after it goes through the fencing operation, it will automatically restart on a surviving node, assuming there's capacity.
Awesome.
545 seconds is, yeah, it's a long time. It's not 9 minutes, I don't think, is it? I don't know. 10 minutes, yeah, it is 9 minutes, isn't it? Yeah. Math in public is never a good thing.
It's terrible.
Yeah. So yeah, close to 9 minutes. So yes, there are, I will say, this is how things stand today. There's a number of things that are the product is working on, engineering is working on to see if we can reduce that as much as possible. There are also other options that you can take. So for example, and I'm getting ahead of myself now, there is where is it? So if I look in here, one of the remediation actions that you can take is to set an out of service taint. So if I click on this, right? So this out of service taint is a Kubernetes level taint. It's a well-known taint that immediately triggers all of the workload on that node to be terminated and then restarted when it, basically with a VM, it's like a deployment with a size of 1, right? When that workload goes away, the control plane basically says, oh, I need to have that workload running, so it restarts the VM, and reschedules it through the cluster. So you as a human or whatever automation you delegate, if you have some sort of external monitoring system that immediately, like 5 seconds in, detects that, oh, this node is like gone, like I fully authoritatively know that those VMs are no longer running. I want to take action right now to restart that workload. You can set that out of service taint on the node, and it will trigger that process immediately. But just be aware, if you do that, and that node is actually still running, and the VMs are still running, on an isolated node or something like that, if when it restarts or when it starts the second instance of that VM pointing to the same disk, it's going to corrupt that disk. So you as the human have to be willing to take on that risk associated with it. And that's why you see, us, I say us, the royal us, Red Hat, OpenShift, like we are conservative with those things.
So a follow-on question to that was, why don't we enable the node health check by default?
So this is one of those, the political answer I'll give is because we want you to have the options of using all of the things that you would like to use and stuff like that. The less political answer is because we ship one OpenShift for all use cases. And so we don't have, even though you can, there's multiple subscriptions. There's an OpenShift virtualization engine, OpenShift Kubernetes engine, OpenShift container platform. When you install it, they're all exactly the same out of the box. And the cluster itself has no idea of knowing what edition of OpenShift it's running. So we have nothing that says like, oh, I'm running on bare metal with OpenShift virtualization engine. I should do these things inside of the cluster. Today, we do have several RFEs and several things that are working in order to do that, provide a better out-of-box experience for known use cases. The first one of those that you'll see, and we talked about it yesterday during the What's New, is I think they called it something obnoxiously long, like disconnected ISO-based registry list install method. I call it the self-contained install method. But effectively, the first use case that's targeting is OpenShift virtualization engine. And so you go on the page, you say, I want to deploy this, and it basically gives you the option of tick the box for OpenShift virtualization, and it will pre-deploy all of the operators that you need inside of there. It still doesn't necessarily configure all of them, but it does pre-deploy them inside of there to eliminate that extra step for what's happening. And I just realized that I'm only sharing the tab, not sharing the window. So I was talking about this out of service taint as though y'all could see what I was saying, and you could not. This is the out of service taint from inside of Kubernetes. And if you see here, right, if a node is marked out of service with this taint, the pods on the node will be forcefully deleted if there are no matching tolerations, basically a toleration on the pod for out of service. And then volume detach operations will happen immediately. So this is the way that you can force the workload to be rescheduled immediately. I think, was that all the questions, Jonny?
Yep, you're all caught up.
All right, so let's jump. Oh, what happened here? Why are we going in full screen? There we go. All right, I'm going to stop sharing because I'm going to share the window instead of sharing the tab. There we go. All right, so what are the components that we need in order to do this? Why are you doing this to me? It keeps wanting to go into full screen mode whenever I do the presentation. Anyways, so what are the components that we need in order to do this? So there's kind of 2 or 3 different things that we have available to us. Technically, there's another machine deletion remediation, but we're not talking about it on this particular slide. So the node health check operator is the one that takes responsibility for fault detection. So as we can see over here, I'm not going to read it verbatim, but basically when the control plane puts the node into an unknown status, the node health check operator is the one that takes further steps to verify and validate that the node is actually down and gone, and then it triggers one of the remediation options based on what's configured. And you can do escalating, so you can do multiple inside of here. So again, self-node remediation relies on agents. So effectively the node, the worker node, will have an agent installed on it that is checking in with both the control plane as well as with its peers. So what happens is the node gets isolated, and the node health check operator, so the control plane and the node health check operator both say, oh, it's unhealthy. Meanwhile, the isolated node, it's still running, it's just isolated, is also trying to connect with those components. And if it can't, after a configurable period of time, it will basically say, something must have happened. I am going to reboot myself in order to make sure that that workload is down. So we have to wait on remediation to begin, basically restarting the workload, until that timeout has happened, that the self-node remediation operator will reboot the node so that the workload is safely down. That can take several minutes, as you can imagine. Fence agents remediation operator is the one that reaches out to the BMC on the node and basically says, hey, hardware controller, reboot the node, reset the node. So this one is generally faster, but has its own set of complications as well. Typically, the biggest one that we encounter is, and Jonny, you and I used to do this when, many moons ago, the BMCs are on a super protected network.
Mm-hmm.
And the problem is the pod that's running on the control plane, that's running in the cluster, to reach out and touch the BMC and say, hey, reboot the node, it has to be able to communicate with that. And so we have to, we work with folks to help them understand, like, hey, firewall rules, or putting an interface on the node that can talk on this network, right? Whatever we need to do in order to make that happen. But this is going to be, by default, the fastest option for triggering the remediation action and then restarting workload. This is all stuff that I already talked about. So node health check. So you can see here, node health check at a high level, it's looking for these unhealthy conditions and then takes action from there. So if the status of the node, when the control plane declares the node to be either unknown or ready equals false, so ready equals unknown or ready equals false, it then waits 30 seconds for it to clear, and then it takes further action. Basically, it triggers whatever the configured remediation is. You can turn this down, again, to 1 second if you choose, or you can extend it up. The other important things to be aware of here are these min healthy and max unhealthy. So min healthy basically says, if there is not at least 51% of the cluster nodes available, I'm not going to take any action. Max unhealthy is the inverse. If there is more than one node that has failed, I'm not going to take any action. This is and can be important when I have, like, my entire network is in a spanning tree loop right now. So nothing can talk to anything, and you don't want to have all of your nodes rebooting needlessly. So it basically says, oh, too many nodes are not healthy, so therefore I'm going to wait for something to happen. We see this with storage systems as well, right? I've got a shelf of disks attached to my storage system. The whole shelf drops. It just lost, 28 or 56 or however many drives. The storage system will typically assume that something catastrophic has happened and just stop in order to prevent any sort of corruption. Where they have a book like HA Deep Dive. Yep, I actually have that book. I think it's that one right there, the yellow one. Anyways, we don't have something similar yet. So the best thing that I can offer is we have this high availability KCS. I'm going to put it into the chat here. So this high availability KCS walks through at a high level a lot of the things that I'm talking about here and provides links out to documentation and stuff like that. But we have talked about creating something like that, kind of going back to the, I'll call it whinging I was doing before of like, there's a lot of stuff going on. We're trying to carve out time to create exactly those types of resources. It just takes time. So node health check recovery is what we use to trigger, okay, the control plane can't reach the node. Do I need to do anything else before declaring the node taking remediation action, right? So any other safeguards? And then down here, we have our remediation templates, which is what we actually do to remediate it. So note that we can use escalating remediations here. So what that does is it tries different things with multiple different remediation agents in order to, hey, maybe I want to start with just rebooting the node, triggering a guest or the underlying hypervisor OS to reboot. Oh, that didn't work. Okay, let me try a BMC remediate. Oh, that didn't work. Okay, now let me like delete the machine from the node or from the cluster rather, in order to force workload to be restarted. So different options inside of their escalating remediations kind of allows you to start with the lowest impact and then move up from there. Downside is you'll see each one of these has its own timeout that has to be, either it has to successfully fail and move forward, or we have to wait for a timeout before it'll move forward. So how can you participate in beta programs? So we publish, and by we I mean engineering, publishes RC and EC releases to the mirrors. So if I go to mirror.openshift.com, and if I come down here to OpenShift v4, and then I go to, oh gosh, it's been a minute since I was here. I'm going to say dependencies, RCOS. So if I look in here, like here's all the way up to 420. If I look in here, yeah, it's not going to have them because we just released 420, but there is this pre-release. So here's the 421 EC. So EC is short for engineering candidate. So this is where you would go and you would look and you can see those. So we talked about this a long time ago. And by a long time ago, I mean like 2 years ago, probably, of the RCs. Basically, when we go into code freeze is when they start creating the RC releases. So code freeze is when we stop making changes, right? Adding features, removing features, updating features, and everything goes into bug fix mode. So each RC release candidate is, as they progress, it's as we have found and fixed more bugs in the existing set of code. ECs, you can still see some features being modified inside of there. So for example, let's say that, I'll pick on the one that you highlighted earlier, right? Node targeting with live migration. Let's say that that feature is taking more effort than engineering expected. If they can't get it into the code base by the time the RC is cut, then it can be pulled out of that particular release. So ECs, you can still see features like, oh, we were able to go faster than expected. We added this feature into this release, or this one took longer than expected. We pulled this feature from this release. That can still happen with ECs. RCs, it's much, much, much less likely to happen. It would take like significantly breaking bugs for that to happen. But anybody can come and join these, so long as you have or look at these EC, right, or pre-releases. You do need a pull secret, just as you would with any other release. You can use a developer account. So developer.redhat.com, register a developer account, and you have access to, I think it's 16 nodes of OpenShift subscription. They're good for a year. And then you just refresh your developer account and keep going. And if you work for a partner, so partners, we can, sorry, I clicked on the wrong button there. Partners also have access to our engineering partner manager resources, so they can also help with getting access to all of that for doing like integration testing with, so if you work for a storage partner, like, oh, I want to test my CSI driver with the next version of OpenShift, like they'll give you the recommendations on which versions work best and all that type of stuff. Let's see, where was I? So self-node remediation, I kind of described all of this before. Jonny, we can make sure to share these slides out on SlideShare or wherever we normally share them at. There's nothing private in these. The workflows that are happening here, this kind of walks through all the different things, all the different paths that it can take in order to determine that something has gone wrong and authoritatively restart that node. So you can see here's that remediation strategy out of service taint as opposed to delete. So the delete workload would be, it goes in and it tries to, basically it does an OC get pod and then filters for that node and then just does an OC delete pod on every one of those. Whereas the out of service taint, the cluster itself handles doing that for you.
So when you do the out of service taint, does it essentially do like a cordon, right? Cordons off the node and then starts to like drain it and all that, or is that what
So
okay.
sort of. So a node that is in an unknown status, the control plane or the scheduler already won't schedule to that node. Furthermore, by putting that taint on there, any workload that doesn't have a toleration for the taint would avoid it anyways.
Gotcha.
So yeah, that's how we don't schedule workload back to a failed node in that instance. But yeah, the status of the node in the control plane being unknown or false for the ready field is going to automatically have workload avoiding it.
Okay, gotcha.
So just some additional things here for self-node remediation config. You can see we do, like if there's a hardware watchdog available, it will use that to trigger the reboot as opposed to a software reboot, right? Doing sudo shutdown -h now or -r now rather. You can see different timeouts inside of here, like the agent that's running on the nodes, how long does it wait and how for like, if I can't talk to the control plane, how long should I wait to do things? If I can't talk to my peers, how long should I wait to do things? Stuff like that. And then down here is the node health check, an example of node health check. So you can see min healthy is 90%. That number that we set here, which can be a hard number or a percentage, that's going to be based on a number of factors. If I have 4 nodes in my cluster and my min healthy is at 90%, well, if I lose a single node, then I have 25% of my cluster unhealthy, which means that it's not going to take any action because that's less than min healthy. If I have 100 nodes in my cluster, min healthy at 90% means I can lose 10 nodes and still it will take remediation action with each one of those. It wouldn't be until I lost the 11th node where it says something has happened, I'm going to wait for somebody to tell me what to do. Fence agents remediation, go ahead, Jonny.
I'm sorry, we got one question again. Is after installing the VirtIO drivers on the Windows VM, the cursor is not smooth. Is this being looked into? I would say just make sure that you've got all the VirtIO drivers installed. Like make sure you got like the balloon drivers and all that stuff. And then I might be showing my age a little bit there by saying that. But then if you're still having problems, then I think the best thing to do is create a Jira issue and just let them know what you're experiencing. I don't know if you want to say anything to that as well, Andrew.
Open a support ticket.
Yeah.
That may be a VNC issue.
Yeah,
Depending
could be,
on there has been some issues in the 4.18 time frame or some of the earlier 4.18 versions where the console was, for lack of a better term, glitchy. So that could be it. But I would say definitely open a support case, if nothing else, because they may either be able to point you to a known fix or workaround, or they will be able to raise that issue directly with engineering so that way they can address it. I've already talked about all this other stuff with fence agent remediation. So one of the issues, one of the other issues with fence agents remediation is you see like we have to put credentials for BMCs inside of here. So you do have to be aware of that. Like sometimes these, you have to be aware of that and take appropriate action. I believe that you can use a secret, if I remember correctly, in order to do this. So it doesn't have to be directly in the custom resource instance, but still somewhere in the cluster is going to exist the credentials for logging into the BMC.
Shameless plug. If it does use the secret, once we find that out, then you can use something like external secrets to dump that secret into the vault. That way, you're not actually storing it directly in a Kubernetes thing. which is supported now on 420, which is awesome.
So slightly older numbers. They haven't done a big test of this in the last few versions. So you can see this is with 416. Depending on the configuration, which one of the agents is being used. Did you click the wrong button, Jonny?
It's my English networking. I have no idea what's going on here.
Depending on which one of the remediation agents you use and how aggressively you tune it, you see that this is sort of the default SNR with 300 seconds timeouts. Same with FAR, and it's a solid 10, 11 minutes for recovery. But we can tune that all the way down. So you see 81 seconds was the floor that we were able to achieve with fence agent remediation and the 1 second setting on node health check. So remember, 50 of those seconds are just waiting for the control plane to declare the node in an unknown state. And then I think when they did this, this was like how long it took the VMs to restart. So probably some of those seconds in that remaining 31 is going to be the VMs actually booting themselves. So yeah, that's where those numbers come from. And then I already showed this particular slide. A couple of quick things to know. So I like to highlight both positives and negatives. I think you all know that about me. So self-node remediation, as you can see, does not require any management interface, right? It can be the fallback if fence agent remediation is not remediating for whatever reason. So remember the escalating remediations configuration I showed way back up at the top of the slides. That's what that's referring to. So the problem with self-node remediation is we don't get feedback about the node reboot. Basically, we set whatever the timeout value is, and we wait that long. And if the node rebooted, we set that timeout to be 300 seconds. If the node rebooted 45 seconds in, we have no way of knowing that, right? We wait out the rest of it until either the node magically pops back in, right? SNR rebooted it and it fixed itself, and therefore it pops back into the cluster, or we just wait that timeout regardless. So that's where this no quick feedback, no ACK comes into play of it is going to be a delayed timeout. Fence agents remediation does have that direct feedback, right? When it can talk to that BMC and say BMC reboot the node, the BMC acts back and says the node is down, we can immediately move forward with remediation. However, there are factors that can affect that from happening, right? Again, we have to have access to the BMC inside of there. If the pod that is responsible for doing that BMC interaction is down, we have to wait for that pod to come back. If the BMC itself is down, we have to wait for the BMC to come back, or we have to wait for a timeout to happen, so on and so forth. So there are things that can affect that. The last thing that I'll point out is if your CSI driver is also not responding, that can affect recovery time as well. And the amount of time that recovers can be unknown. So what do I mean by that? So with any workload, any pod that has a persistent volume, when we go to terminate that pod, one of the steps that happens in there is we request that the CSI driver, the CSI controller, unmount that disk from inside of there. So when that PVC is unmounted, then it says, okay, it's safe for me to move on and I can do whatever, right? I can reschedule the pod, I can move forward with that. If the CSI controller is not responding, we have to wait for that to time out. That is a 6-minute timeout. If for whatever reason, so let's say that I lost the node that was lost happens to be like the most important, most critical, like holding all of the cards node in my cluster. So it has the BMC controller pod, it has my CSI driver controller pod, right? All these things that can extend out that process because the node failed and I can't take any remediation action because my BMC pod is down. I can't take I can't forcefully terminate the pods because my CSI controller pod is down. So I have to wait for the standard timeout for pod-based workload, which is 5 minutes, for the pods to restart somewhere else in the cluster. At that point, theoretically, hopefully, The BMC pod comes back online, it reboots the node at that point. The CSI pod comes back online, it unmounts all of the pods, and so therefore when we set that out of service taint, it's able to immediately then begin rescheduling those workloads. There is a condition. So after 6 minutes of the pod being in a terminating state, a pod with a PVC being in a terminating state, it can and will forcefully unmount that volume. Generally speaking, the CSI drivers don't like that because it means that it doesn't know if that volume was successfully, safely unmounted from the node that it was on before. So this can have potential, I will say potential. I have not seen this personally, but it can have potential ramifications with things like, think a iSCSI volume or a fiber channel volume, where the storage array is expecting it to be mounted by a specific WWN, or it's mapped to a specific, I group. I think they're called I groups. Gosh, it's been a minute since I did iSCSI. Anyways, it's mapped to a specific set of nodes or something like that, and I'm relying on the CSI driver to remap it as it's mounting across those hosts. So sometimes I can end up in scenarios where the storage device itself isn't aware of the precise status of that LUN. Or excuse me, the CSI driver isn't aware of the precise status. So we want to be careful with those things. So, and this is why we Red Hat, the product OpenShift, is very conservative because we want to take every measure we can to help make sure that data corruption doesn't occur. I used to work for a storage company. Rule number one is you don't corrupt data. You don't lose data.
Yeah, that's bad.
Yeah.
Always bad.
All right, so I've rambled through way more and talked way more on slides than I wanted to, but hopefully it was useful. So I've got a cluster here. So this is running 4.20 RC3, and it occurred to me that this is an RC release, so hopefully it doesn't mess with things too much. I'm hoping that the operators that we want are available and not because sometimes RCs, if a particular operator isn't a part of core OpenShift, it's an out of sync operator, it won't show up in the catalog. So hopefully that doesn't affect us here. I guess we're going to find out. Let's see. So Lightspeed. I want to configure node health check for my bare metal nodes. Please help me. So let's see what Lightspeed has to say. Oh, well, that went well. Well, I guess I can't use Lightspeed in order to test this. That's disappointing. Oh, I'll have to figure out what happened to my Lightspeed. Clearly, it lost connection. I used this literally yesterday. I don't know. Apparently, it's having trouble connecting to whatever the LLM behind the scenes is. I don't even know which one is configured anymore.
Oh, let me see if there's anything crazy going on.
Yeah, is AWS broken again?
Yeah, I was like, hey, you never know. No, everything looks good though, so it's not that.
All right. So I know at a high level what we want to do. So the first thing that we need to do, actually, I'm going to follow the documentation here. So docs.redhat.com.
So Khalil asked, do you think combining SNR and FAR gives you the best reliability, or does it just complicate the recovery?
I don't know. So I say that because in theory, you can take, as I pointed out before, you can have multiple different methods in case one of them fails. So going back to what I was saying before of escalating remediations, maybe use FAR first, but through bad luck and fate, FAR fails. So we give it its 30 seconds or 60 seconds, whatever, and then we move to SNR. And then we rely on SNR to go in and forcefully reboot the node. And after a timeout, it then goes in and sets the out of service taint, and now my workload will get restarted. Relying on one or the other, I don't know. I'd say I would want to do some testing in various scenarios and see what happens, and whether or not, like, let me think of how to say this. At what point is it more efficient for me to rely on a human and the alerting system to come in and trigger something to happen versus waiting on 10 or 15 or 20 minutes worth of timeouts to happen inside of there?
Right.
I don't
Mm.
know. And I throw out those numbers of 10, 15, 20 minutes. I have no idea what the actual floor for those numbers are. At least not today.
Yeah. That's a solid answer though, man. I mean, I feel like I know I can appreciate that, right? Just it is what you got to figure it out. Who knows?
Yeah. So I'll point out, and for anybody who's been doing Red Hat for a while, right, Jonny, you were on the service side, you were a consultant, right? Red Hat we're really bad about being opinionated on things, right? It's almost always
Mhm.
like, oh, here's the 30 different ways that you can do this thing. Which one do you want to use, for your scenario?
Yeah.
And depending on who you're talking to, they may have more or less knowledge on some of those methods than other methods, and so maybe they skew our perspective or something like that. But generally speaking, Red Hat is like, we're really terrible at just having opinionated content. For the virtualization space, like, we are trying to fix that. We're trying to give better information and like help explain things. So if I go to red.ht/vert arch guide, why is access to, what is happening? So I'll post this link in here. So the architecture guide provides sort of a lot of these concepts and, I'll say, decision points that we want to make when implementing a virtualization solution, and walks through what a bunch of the different options are. So somewhere down in here is like virtual machine high availability. And it again walks through at a high level a lot of the things that I've been talking about here, right? How do we do failure detection? Well, there's control plane status updates, node health checks, and machine health checks. I haven't talked about machine health checks yet. Fencing, right? And so additional details, and it points out, basically it says, hey, you want to do high availability, like, here's kind of how it works, but all of the details are in the workload availability documentation. So this is where all of that, this is the documentation I was looking for, by the way, so that was serendipitous. But this is where it walks through all of these things in much greater detail. So again, going back to the, like, hey, here's all of the options, you figure out which one you want to do. So we are working on, and we have been asked, my team has been asked to create opinionated example deployments. So one of the things that we're working on is exactly that. Like, hey, here are the requirements and the constraints and the example architecture of doing that. So I want to deploy 1,000 VMs that average 4 CPUs and 12 gigabytes of memory, and I need to have memory overcommitment of 4-to-1 and CPU overcommitment of 8-to-1 and high availability with a 90-second recovery time. Da, 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 da. And then what does that implementation look like? And oh, we decided to go with 32 nodes in the cluster, and nodes of this size with this many network adapters, and the network adapters are configured in bonds with live migration traffic separated onto its own bond, blah 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 blah. So that's one of the things that we're working on for the work towards the end of the year, is when we're hoping to get a lot of that published.
Nice. Yeah, that's gonna be awesome. Because what did they used to call that back in the day? It was like they used to do one for satellite where it was like, hey, here's your guide. Here's how everything was configured. It was like just this nice operating reference architecture, right? Like, here's an operating guide. I can't remember what the verbiage was that they used, but I feel like some of that stuff is kind of, we need to go back to that a little bit in some of these situations.
Yeah, and to be clear, I'm using the term example implementation or example architecture. Reference architectures are something that our partners create. So
Hmm.
if I go to red.ht/works with Vert, so if I come to this page, you'll find like a lot of our hardware partners and stuff. So here, we'll pick on hardware infrastructure. So Cisco, and then from here, Like here's a CVD, a Cisco validated design for FlexPod data center with OpenShift virtualization. It's like this is a legit full-on reference architecture that comes from our hardware partner Cisco in conjunction with or in partnership with NetApp. So if you want like a precise, exact implementation guide, that's the reference architectures that come from our hardware partners. And this goes down all the way into like the models of hardware that they use, the exact, I'm sure if I scroll down here far enough, it tells me like, here's the wiring diagrams,
Oh yeah, that's a
here's all
real
the
deal.
VLANs and how they're doing it, like all of the things inside of here. Like Red Hat, we're a software company. Like we don't have hardware.
Mm-hmm.
And even if we did, like I don't know that I am qualified to be able to make decisions, on the right way to do things with Cisco UCS blades or NetApp storage. I mean, it's been I, I, I've now been away from NetApp longer than I worked at NetApp by several years. So I am no longer qualified to make architecture decisions on NetApp and how to use their stuff. So reference architectures are the realm of our partners, but example implementations, example architectures of, hey, when you have this scenario, like this is one way that we would do it, and try and identify decision points and where you might want to make a different decision. That's something we can definitely do. Let's see. So I don't need that tab anymore. I don't need that tab anymore, and I don't need that tab anymore. So this workload availability documentation is what we want. You can see we're on the 25.8 version, and I want to use, let's see, node health check. Installing a node health check operator by using the web console. So operators, operator hub, select node health check operator, then click install. So I'm just going to kind of walk through this. Note in 420, and this may have even been in 419, but 420, the operator hub is now ecosystem. So if you see that in your left-hand menu, that's what it is now. Oops.
Yeah, when Peter and oh my God, I can't believe I'm forgetting his name right now. When Peter came on the last time, he was talking about like this drop down, dropping.
Yep. So node health check operator. So yes, this is the one I want. Stable, all namespaces, OpenShift workload availability, automatic. Okay, we're not going to install using the CLI, so creating a node health check. Wow, it just, okay.
Bye.
Yeah. Okay then. I don't know how to interpret that. Okay, so come on. Something must be restarting the
Yeah.
API server or something.
Yeah. Your authentication pods.
Yeah, it's not. Oops, cluster operators.
There it is.
Cluster or operator. Why is OLM? Oh, it's just blocking a update to 421. Oh, okay. All because ODF isn't compatible. Like, yes, I would hope it's not with a EC release. Oops, not favorites. I want ecosystem, installed operators, and now we have node health check operator. So node health check. So now I can create a node health check. I'm just following the documentation over here. Enter a name for the health check, specify the remediator. So we're going to call this one live stream because I'm feeling extra creative.
Yes.
So self-node remediation is disabled because templates can't be found. Please reinstall the self-remediation operator. That's because self-node remediation is not installed. Self-node. So self-node remediation operator. So we'll click on this one. Do I need to worry about you, Johnny?
I don't even know what's happening right now. It just dropped. Like I was checking my Unify stuff to see if I could see it, but I'm not seeing anything. It's because my kid's home. That's why.
Eating up all the bandwidth.
Yes.
So it's now occurring to me in the documentation why they have the remediation operators before the node health check operators, because node health check relies on the remediation operator. So that's, I skipped that step. So we're going to go in and we're going to install SNR. Yep, that's fine for the namespace to already exist. Let's see if I get booted out again. Okay. So configuring the self-node remediation operator. So the way that this works is we define the self-node remediation config, but then we rely on node health check to actually trigger that to happen. Basically, it maps them together. So what we'll need to do, I believe, is we'll configure the self-node remediation config, which feels redundant to say, and then we'll go in and tell node health check, use this self-node remediation config for these nodes.
So you create this SNR and then reference it to the node health check. Is that what you're
Yep.
saying? Okay.
Yep. Self-node remediation. So now I have this self-node remediation config. Oh, it already has one in here. Well, that's interesting. So API server timeout. Let's see. What values do we want to use here? So I do know that I want to set my, let's see. So soft reboot is enabled. If there's a watchdog, I'll use that one. And then I want to make sure that it uses the out of service taint. And I think that's configured in here. Yep, okay. Specify, yeah, okay, we don't need to set any of those, I don't think. Oh, I bet it's probably set in the node health check. Oh, here we go. CRD defines a remediation strategy. Following remediation strategies are available, so we want out of service taint. So you can see resource deletion, right, removes the pods on the node, so it goes through and deletes. So what it means by that is, so if I come down here to compute and nodes, and let's say it's node 7 that fails, if it's set to resource deletion, it'll basically look at all of the pods that are here and just go through and delete them. Right? Again, the equivalent of an OC delete. Whereas out of service taint, if I look at my node details here, down here, I think is where taints are defined. It's a lot of labels.
Mm-hmm.
So basically, this is where I would set that, or where you would see that out of service taint get set. When that happens, the control plane is the one that takes action and does all of the things for removing the workload and making sure all the appropriate things are going on inside of there. So out of service is what we would generally want. If you're using machine deletion remediation, which is only available when you are using like platform bare metal or platform, AWS that has bare metal nodes. So you'll have a machine set for your nodes. So you can see this one is not using a machine set, but effectively what it would do is it would just delete the node from the cluster. Like if I come over here and select delete node, it deletes the node from the cluster, which immediately removes all of the workloads in the control plane. It removes the references to all of that and triggers a rescheduling of everything to happen inside of there. So that's what machine deletion remediation is. Machine health checks. So we've talked about, just because I see it here, so we've talked about node health check. So node health check and machine health checks are mutually exclusive. So node health check is an operator and a set of agents that run that do basically monitoring of the nodes. Machine health checks rely on that machine API provider or cluster API provider in order to report the status of the node. So again, if I'm using Metal Cubed is already interacting with our BMC, with our underlying hardware, and it can, if I'm doing bare metal IPI, it can report hardware health status. And so I can use that in order to trigger remediation actions from there. But again, that's dependent on basically bare metal IPI or something like AWS, Azure, Oracle, IBM Cloud, bare metal type of cluster deployment. All right, so automatic. So checks for if the out of service taint strategy is available on the cluster. Basically, it should be with all modern versions of OpenShift. I think it's either 4.14 or 4.16 was when the out of service taint was added to the Kubernetes, the upstream Kubernetes API. And that was when it was pulled into OpenShift. So I think if we leave this at automatic, it should be fine. It should automatically use out of service taint. So we'll keep it at automatic. Yep, self-node remediation template. Okay, so let's come over here. Where was I? Installed operators, node health, node health check operator, node health check. Am I crazy? Was there not one here before?
Did you remove it to install as SNR?
I don't know.
I don't remember.
I swear I was looking at one of these. Self node. Oh, this is node health checks, not self node remediation.
Oh, yeah, duh.
So here's our self node remediation config. Here is the configuration that we have for this. As an aside, one of my side tasks is to work on getting as many of these things in. So like if I click on edit here, it's going to take me to this YAML. Getting as many of these things as possible into like just a form from inside of here, so we don't have to go in and look at YAML and kind of guess at things. So if I create one, I can use a form and go through, and it helps me with a lot of this, like what are these things for? What do these things mean? And all this other stuff. But if I edit it, I can't. So as much as possible, getting things into forms when I'm editing them and stuff like that. The UX team is probably tired of hearing from me about all these. But it is nice to be able to see like save time to assume node reboot seconds, right? It tells you exactly what this means and like some considerations. So you can see here, this is extremely important as starting replacement pods while they're still running on the failed node is likely to lead to data corruption. In an effort to prevent this, like you see all of these things that it goes through. So one of the important reasons, at least in my opinion, as to why we should be doing that. So I'm going to leave this as is. I think that this is probably fine. Self-node remediation config, what's the name on this? Name is just self-node remediation config, okay. So with that configured, so configuring the remediation operator, so we've got this done. Okay, this just goes into more. Okay, that should be good. We're not going to use defense agents. We're not going to use machine health checks. So now we need to do creating a node health check. So we're going to go to compute node health checks, create node health checks. So if I come down here to compute and node health checks, I'm going to create a health check. Specify the remediation type, self-node remediation. So we're going to call this, oops, if I can't type. So API version, you see it's self-filling all of these things. We want worker nodes, which fills in my 3 nodes for me automatically, which is very convenient. So min healthy, so with only 3 nodes in my cluster, this means that I can only lose 1 node, which makes sense because if I lose 2 nodes, my control plane is going to go read-only anyways.
Mm-hmm.
And healthy conditions, so type ready. So let's talk about some of these options. So if I look at, let's open this up in a new tab. So what that's referring to is this status right here. So if I go into status equals ready, and or I look at the YAML over here, and I come all the way down to wherever the status is at. So status, there'll be one of these things down through here that is like the overall status being set to ready. The other configurable options or the other values here are like, if this node starts experiencing disk pressure or memory pressure or PID pressure, take action then. So it doesn't necessarily just have to be, oh, the node is not ready or no longer in a ready status, but it's experiencing disk pressure and I want it to do something before, like memory pressure, like before it starts to evict pods. So, and that's where that the various remediation actions become healthy. So type is, so overall status is ready, not being set to true. It can be either false or unknown. So I'm going to set this down to, let's go with 30 seconds. I'm going to do the same thing down here. I used to remember what the difference was between false and unknown, and I don't remember what that is anymore. I'd have
I have
to
no
look it
idea.
up. I'd have to look it up in the Kubernetes documentation. Excuse me while I cough. Okay, so we created a node health check here. And I believe that is all we need to do. So at this point, yep, been healthy, okay. Yeah, at this point that should take care of it. Ready, false, okay, status is enabled. So the question is, do we want to actually pull the plug on one of these and see what happens?
Oh yeah.
Do I have the ability to restart my node? I'm trying to think. Alan, if you're watching, I'm about to shut down a node.
Sorry.
Hopefully we can get it back. Let's see.
Love Sully.
It's fine. It's fine. It'll be
Look,
great.
everything's fine.
It'll be great.
Fine.
It'll go wonderful. So I'm going to choose one of these guys. We're going to go to terminal. We're going to simulate a failure. So I didn't cordon, I didn't drain, I didn't do anything here. Like let's see what happens. It occurred to me that I don't know if I gave it enough time to actually deploy all the components, but I guess we'll find out.
Hope you're ready, because I am.
We just YOLO'd that thing, and hell, let's hope for the best. All right, let's see, nodes. So you see it's still ready. Like the node is definitely not ready at this point. But again, it'll take at least 50 seconds, depending on where it was in its cycle and how long it takes the various agents to terminate on the node. So there, now it's in not ready status. So in theory, I want to look here. So it says not ready. If I go to details, like somewhere down in here, let's see what taints are set. Unreachable, okay. No schedule, no execute. Status is not ready, so I'm trying to find. Yeah, okay. All right, this is all the.
Yeah.
So status, okay. Yeah, conditions, memory pressure. So status is unknown. So even though it summarizes it as not ready, so the GUI makes it into a pretty not ready, the specific status is unknown at the moment.
Mm-hmm.
And let's go back down here. We should still have our same 2 taints inside of here because we should be waiting on the node health check timeout to be happening. You can see remediating 1 node. I wish it gave me more details than that.
I know. Like
What
little graphic to it or something, you know?
unhealthy. Okay, so unhealthy nodes, node 07. Okay. Self-remediation automatic strategy template. I'm going to assume, did we create that? I'm going to assume that that exists.
Yeah, you'd probably see it bombing out, right?
Self-node-remediation. Nope, custom resources. So self-node remediation template.
Yes.
Oh yeah, it does exist. How about that? Okay. Come back up here to nodes. Yeah, I know. Poor ODF is going to be angry.
Oh yeah.
So we're still at only the 2 taints. I should have started a timer or something when it went into the not ready status.
Mm.
Not workloads. Ecosystem installed. Peer request timeout. So what I don't know is what's the timeout that it's going to set. Okay, so it did create this self-node remediation object. So this is what the API, let me think of how to say this. When the self-node remediation operator, or excuse me, when the node health check operator determines that the node is unhealthy, it will create a remediation object. So in this case, because we're using self-node remediation, it creates a self-node remediation. If I was using fence agents, would you create a fence agent remediation object? And this is what triggers the self-node remediation operator to then begin its process. Again, this is something that you could create manually without having to wait on all those timeouts. Just be aware of the ramifications. But I'm trying to figure out, yeah, so remediation strategy is automatic. You gonna give me any events? Nope.
What are you doing?
Yeah, I don't know how to find like where in the timeout am I? So created 3 minutes ago. So
Is there a
that at least
log on a pod that we'd have to check?
probably. Let's see. I want not favorites. I think it's in the workload availability. So node health check controller manager, self-node remediation controller manager. Let's take a look at this guy. Oh, so that's fun. So so now it just restarted the self-node remediation controller manager because the controller manager was running on the node that failed. See, it was on node 7. So it couldn't have taken any action until that pod just restarted. So that's interesting. So let's see what it's going to do. Setting SNR's time to assume the node has been rebooted. So it looks like it's now assumed that the node has been rebooted. So let's come down here to our nodes, scheduling disabled and not ready. So that tells me that most likely our toleration, or a taint rather, has been set. Yep. Being
Nice.
remediated. So in theory, now it is taking action to restart any workload that was on there. If I come over here to pods, yeah, see they're all going into the terminating status. So that's it. That's it remediating the workload.
That's awesome. And the reason why it took so long is because the SNR was actually running on the node that was removed, and it had to wait for itself to figure out where it was at and then kill it off. Okay.
Yeah, that would be, that's my assumption at this point. So, see if we have any, did we have any VMs on here? Vert handler. Doesn't look like it. Yeah, these are all in the completed status. But anyways, it should now be going through and restarting all that workload, or the workload that can be restarted. Some things are going to be penned to the node. So like you'll see core DNS, like that's a daemon set, so it's going to keep being there. etcd, same, because it's also a control plane node, right? FRR, that's part of UDN for routing. Yeah, see how this list is slowly shortening? All the terminated pods have now finished terminating and are restarting elsewhere. So it worked.
Nice.
It's always nice when a plan comes together.
That's right.
Yep. So what would happen if the node came back immediately? So let's say that we remediate, the node successfully remediates, it reboots and it comes back, or it legitimately failed, right? The power blipped and it restarted and came back, or something like that. Effectively, when the node rejoins, it's not going to have any of that workload that's running. So as soon as it registers or rejoins the control plane, and the control plane says, hey, what workload you got running? And it says, only these things. And it's going to say, oh, crap, let's reschedule all the things that we thought you had. And it's going to reschedule, back through.
Nice.
So, yeah. It's funny to me that these still report as running, though. Like, clearly they're not, but it's interesting that they are.
Mm-hmm.
Do we still have our, still our same 14ths. It's strange. I'm surprised we didn't see the out of service taint, because I would have expected that to be, maybe for whatever reason, the automatic policy set it to delete instead of out of service.
Oh, yeah.
I'd be curious. I don't know. I'm sure somewhere in the logs, somewhere in one of the pods is where it declared that, like whatever it used to test and determine. So interesting. So node health checks. So you can see this one is still remediating. If we look at this, go back to our YAML here, we can get a precise status. So I will say, I'm going to chat with our folks and see if we can get a couple of RFEs put in. So at a minimum, like for these node health checks, when it goes into the remediating status, like I want more information here. Like I should be able to click on this and be able to see like precisely what node is being remediated, what the time is, like what's the exact status, and all those other things. Like clicking this gives me nothing. Clicking on the YAML gives me some information, but like, clearly I now need to jump over to the whatever the remediator is. So in this case, the self node remediation, and look at its pods and probably its logs to get a more precise status. So aggregating all of that into one place would be phenomenal.
Yeah.
It's all there. It's just scattered across various places.
That's pretty cool though. It worked like a champ.
Yeah, and I would have, so technically we do have BMCs on these nodes, so I could have done fence agents, but I chose not to do that because then I'd have to expose the password.
Mm-hmm.
So in this instance, self-node remediation did what it was supposed to do, which is fine. But fence agents is, generally speaking, the faster method for restarting workloads because we don't have to wait. Assuming the BMC acts back immediately or within a few seconds, we don't have to wait on that SNR timeout.
Yeah. That's the old Stoneth, right? Shoot the node in the head, shoot the other node in the head. Like,
Yeah.
right, it needs to kill it, just blast it. Yeah.
Yep. Yeah. I will point out, I know for Red Hat folks, if you're happen to be watching this in Slack, there's been lengthy conversations about how we can improve this. I know engineering folks have some awareness and some ideas of like how we can improve, but them, they call it a spike internally. Them doing research projects doesn't mean that anything will get implemented or any timeline for implementation and stuff like that. But I know that they're aware of things like right now we rely heavily on the network for doing heart beating, for doing availability verification and stuff like that. Like, how can we also use storage? Because a lot of times we'll have fiber channel or something like that we can use as a heartbeat method. So I know that they're doing some investigation into what that looks like. Again, no guarantees that that'll ever happen or anything like that, but it's definitely something that they're aware of. I will point out somewhere in the config, I didn't look through the documentation. Clearly I was just skimming through it. It is possible to create multiple health checks for multiple network interfaces. So if I have, on my node, let's see, go to networking and node network configuration. So on my node, if I have, and this one only has one active interface, but let's say that I have, this is my machine network where my primary interface is. Maybe this one is what's running my IP-based storage. Maybe this one is what's doing live migration. Maybe this one doesn't have an IP address and it's being used for VLAN traffic for EMs. Well, I can set up health checks that check on each one of these interfaces so that, maybe something happened on this network and it's down, but these other two are still up. And I can use that as a verification that the host is still running, everything is still running. We don't need to remediate. It's just something blipped over here. Whereas maybe on the storage network, like, oh, the storage network has been down for 30 seconds. That means all of my, NFS and iSCSI VM disks are now like locked, right? They're no longer valid. So I do need to take remediation action on that one, even though the primary network never went down. If you haven't seen this, I think we started this interface in 4.18. So if you haven't seen this interface for networking stuff, it's pretty cool.
Yeah, I love it.
Yeah, if you click on node network configuration, you might see this by default because this is the one that's been in place for ages. If you click the very tiny little star spider web looking thing up here in the corner, it'll switch over to this interface. They are making improvements to this and how these organize themselves and stuff like that, but I really like it because I can click on one of these objects and it shows me the details of it. So I can go through and see the exact config, and if I want even more details, I can click on the YAML, and it's if you've ever used nmstate, the full YAML output of nmstate is basically the same thing. If I do oh gosh, now I'm going to forget the nmcli command, but it's the same as the nmcli command to like dump the interface config. That's what I'm looking at. So that's my physical interface. If I come here to BREX, right, it's going to do the same thing. I can see some information here, like this is a bridge, an OVS bridge, no less. So this is the one that's used by OVN Kubernetes. And on top of that, I've got another one, I think. Yeah, this is the northbound bridge. I can never keep track of these things. But anyways, lots of stuff inside of here. I haven't looked at any of the UI improvements really in 420. I know that there was a number of them that have happened. The engineering folks, we've been doing a lot of work with them on improving the overall UI with OpenShift and especially OpenShift Virtualization. So kudos to them for all of the amazing improvements. Yeah. So that's all I got on this whole subject. I'm really pleased to see that worked with a minimal amount of pain.
Yeah, that was awesome.
I was expecting, I was not expecting it to pre-create some of those objects, and I blindly following the documentation, so things like that remediation template, I was very happy to see it created for me. That's awesome. Because I legitimately I saw that it needed that, and like, oh crap, we need to go and create that, but no, it handled it for us. So that's awesome to see.
Yeah, and that's nice too. That's a good user experience where it's like that way you're not sitting there creating a bunch of different things to get the thing working.
Yeah,
just works out of the box.
So you can see the top level alert here telling me that nodes are down. Things are not happy.
Nice.
All right. So last couple of minutes. Any questions? Any thoughts? Comments? Feel free to put them into the chat. As always, if you are not watching us live, if you're watching a recording of us or anything like that, feel free to reach out to Jonny or I. I'd love to say that we're on Slack. Technically, we are on Slack on the Kubernetes Slack channel, but I don't actively monitor it. So it's when the Slack channel sends me an email saying that I have messages is when I go look at those. Yeah. So the fastest way to get a hold of us is email, which is why both Jonny and I have our emails here on the screen. So you can reach me at Sully, Sully at redhat.com or Jonny, Jonny at redhat.com. That's by far the easiest and the fastest way to get a hold of us. We'll do our best. We both regularly drown in email, so sometimes it does take us an extra day or three, but we try and get back, at least acknowledge that you've sent us something relatively quickly. And if it seems like we forget, don't be afraid to keep harassing us and pestering us, or make sure to include both of us as well. Yeah. Any last thoughts, Jonny?
I uploaded the deck that you had to Speaker Deck, and I put the link in the thing.
Thank
chat. So yeah, that's all. It's all ready. Yeah, I think next week's gonna be catching up on like what's new in 420. We'll actually look at 420 clusters and kind of see. Maybe we can do a side by side on some of the things. But yeah, it's gonna be awesome. Yeah. Next couple weeks are gonna be good.
Yeah, I'm looking forward to it. I have not been deeply hands-on with 4.20, not with the GA at all, and only briefly with the RCs. So I've got some time set aside this week to get some stick time with it and kind of poke at the new features and stuff like that. If anybody has any requests for features that you saw in the What's New that you would like to see a demo of or see us dive more into, let us know. But if you've ever seen us do the What's New in version for admins, we go through and we look at the big list of features internal to Red Hat. We have what's called a whole company readiness sheet that has the full list of features, and we try and pull those out for the ones that are relevant to us.
Yeah.
All right, Jonny. Any last words?
Got to be back in the saddle. Let's keep it going.
Yeah. See if we can hit 2 weeks consecutively. Yay!
Oh my God! Yeah, crazy year.
It has been a crazy year, but like you said, our goal, and both of us have talked about this multiple times, of getting back into the habit and being more consistent being here. So thank you to everybody who's joined us today. We appreciate your patience, and we appreciate all the interactivity. Thank you so much for all the questions. That's the main reason that we're here, is to help answer questions and chat through things. So with that being said, as always, don't hesitate to reach out to us, and we will see you all next week.
See ya.